All right, guys, here we go. Last two questions. I have some bad news for you. I added up the times for the previous videos, and it's just a little over 60 minutes, which means we have almost 15 minutes for the remaining questions, which means we have enough time to do both of them. So I'm sorry, guys. We're going to do both of them. No cancellations this time. Okay, number 12. Number 12 says x to the fourth plus x to the third plus 7x squared plus 9x minus 18. So counting the sign changes, these are all positive. Only this one's negative. There's only one sign change, which means exactly one positive 0. Right? That's positive sign changes. And then negative sign changes. You've got f of negative x is x to the fourth minus x third plus 7x squared minus 9x minus 18. That's one sign change here from positive to negative, then back to positive, that's 2, back to negative, that's 3. So that means 3 or 1, negative 0. Okay, anytime you have an odd number, that means for sure you have at least 1, right? So, because it's only 3, it's 3 or 1s are your only options. And at least 1 here, so that means you got 1 of each, at least. Now let's look at what are the possible rational zeros. So in this case, 18, p should divide that, and q should divide 1. So possible, good recovery there. Rational zeros are plus or minus 1, plus or minus 2, plus or minus 3. Just factors of basically 18, right? Plus or minus 6, plus or minus 9, plus or minus 18. Let's look for the positive one first. So we'll just check 1 to begin with. We're going to run our synthetic division. Coefficients of my original polynomial are 1, 1, 7, 9, and negative 18. So here's the synthetic division. 1 comes down. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. Plus 7 is 9. Times 1 is 9. Plus 9 is 18. Times 1 is positive 18. And yes, lucky, first one. That actually reduced. So that means the resulting polynomial is x to the third plus 2x to the second plus 9x plus 18. We already found our first 0, which is 1. Okay, good news. Let's continue on again. And let me just go to my inspection. Let me just look. Actually, oh, you know what? I know that there's no more positive zeros because there was exactly 1, right? So that means looking back at my possibilities, I'm going to get rid of all the possible positive values and only look at the negative ones. So next, let's check negative 1. Just real quick by inspection, if I was to put a negative 1, this would be negative, that would be negative, but the other parts are positive. And 1 plus 9 is not going to be enough to overcome the 18 and the 2. So that's not going to balance out to 0. So I'm going to skip the negative 1 and go to negative 2. So I'm going to put negative 2. Run my new coefficients here are going to be 1, 2, 9, and 18, right? Pull that 1 down. 1 times negative 2 is negative 2. Plus 2 is 0. Times negative 2 is 0. Times plus 9 is 9. Times negative 2 is negative 18. Oh, sweet. 2 for 2. So that one is 0. That means this is the resulting polynomial. And oh, beautiful thing happens here. This is x squared plus 9. Notice there's no x term. So whenever that happens, it makes it easy for us because, well, first of all, this negative 2 was the other one of the other roots, right? X squared plus 9, that's irreducible, and that's easily factorable into x plus 3i and x minus 3i. Yeah, so anytime there's no x term in the middle, you just basically take the square root of that, tack on an I, and make it positive, negative. Why does that work? Because, just kind of work backwards here with me. If you're to FOIL this thing out, you've got a difference of squares, right? So you've got x squared minus 3i squared. But that's x squared minus 9i squared, right? If you square the 3, square the I. And so, but I squared is negative 1, so this is just x squared plus 9, which is what I had, right? So anytime you have no x term, then it always works out like that. Just take the square root of whatever that number is, tack on the I, make sure you have the conjugates. Okay, so all that to say, we actually have the answer already. Wrong one. We got all our zeros. Easy one. 1, negative 2. Oh, sorry. X plus 3i is the factor. The 0 is 3i and negative 3i. Yeah. If you want to think of as conjugates, guys, you know how we said like the conjugate if a plus bi is a minus bi? Well, in this case, it's like 0 plus 3i and 0 minus 3i. If that confused you, like why those are conjugates of each other, I never thought to mention that before, but that's kind of justification for it. Okay, let us move on to the last question then. Great, just one more. Let's knock some of this out. No one crack here. Nice. Okay, almost done, guys. Last one, number 13. Okay, start with the sign changes. Sign changes starts from positive here, right? To negative, that's 1. To positive, that's 2. To negative, that's 3. Back to positive, that's 4. Back to negative, that's 5. Wow, okay. That means we have 5, 3, or 1 positive root. Okay, now let's look at f of negative x. Okay, that would be negative 2x to the 5th minus 11x to the 4th minus 19x to the 3rd minus 17x squared minus 17x minus 6. No sign changes, which means 0 negative roots. Okay, that's useful information because that means I don't have to even bother checking any negative roots. Now let's look at the possible rational roots. So possible rational roots for zeros. Okay, looking at P should divide 6, Q should divide 2. It's P over Q. And remember, only the positive ones. There's no negative ones. So it's going to be 1, 2, 3, or 6. Right? That's if you divide by 1. And then also, if Q is 2, you could have 1 half. 2 halves, which is just 1 again. 3 halves. Or 6 halves, but 6 halves is just 3 again. So those are my only possible rational or integer roots. Yeah. Okay, so, we're going to start with the usual. Start with 1. Yeah. And just see what happens. So 1. My coefficients are 2, negative 11, positive 19, negative 17, 17, and negative 6. Do the usual. 2 comes down. 2 times 1 is 2, plus negative 11 is negative 9, times 1 is negative 9, plus 19 is 10, times 1 is 10, plus negative 17 is negative 7, times 1 is negative 7, plus that is 10, times 1 is 10, plus negative 6 is 4. Okay, so no luck there, but at least we knocked out one of the possibilities. Okay, let's move on to 2. I'm going to do it over here. Same coefficients. Okay, 2 comes down. That's 2. 2 times 2 is 4. Plus negative 11 is negative 7. Negative 7 times 2 is negative 14. Plus 19 is 5. Times 2 is 10. Plus negative 17 is negative 7. Plus times 2 is negative 14. Plus 17 is 3. Times 2 is... 6. Yes! Negative 6 plus 6 is 0. All right. We found another one. Okay, sweet. So, I forgot to rewrite this thing. If Wait. What was I doing? Oh, no. Yeah, this is the first zero we found. Okay, so then that means the resulting new polynomial, we've knocked it down successfully by 1 degree. This is 2x to the 4th minus 7x to the 3rd plus 5x to the 2nd minus 7x plus 3. All right. Okay, now looking at this thing again, we've managed to reduce some of our possibilities here, right? Because now this is my new polynomial. P has to divide 3. So I no longer can have 6 as a possibility. So I've knocked one out. 2, it's possible I have 2 as a double root, so I'll leave that in there for now. 3 is still a possibility, so okay. All right, let's go into check 3. with our new resulting polynomial here, this guy. Okay, so I'm checking x minus 3. This is 2, negative 7. Actually, wait. Before I do this, let me just inspect this real quick. Let me look at this guy. If I was to plug in 2, what would happen? Nah, never mind. I can't tell off the top of my head, so I'm just going to check 3. Okay, so it's 3. Here's 2, negative 7, positive 5, negative 7, positive 3. Okay, 2 comes down. 2 times 3 is 6, plus negative 7, negative 1, times 3 is negative 3, plus 5 is 2, times 3 is 6, plus negative 7 and negative 1, times 3 is negative 3, and plus 3 is 0. Oh, we found another one. Awesome. Awesome, guys. So now this is the resulting polynomial is 2x to the third minus x squared plus 2x minus 1. Okay, we're down to a cubic. Now we're basically back to question numbers 8, 9, 10, right? Let me just, before I forget, let me just highlight that these were the roots. So far I have 2 and 3 being roots, yeah? Okay, I'm gonna have to knock it down one more, okay? 2, negative 1, 2, negative 1, okay. Oh, interesting. Oh, okay. So, I could, at this stage, guys, I could continue the way I've been doing, right? I could just like try another one, and I kind of have an intuition that 1/2 is gonna work, I think. But I have another option here. So I could just continue on, check the rest of my possibilities, check these again if I need to, check those again. And you're just gonna continue reducing it down to a quadratic, right? But I see something here. Look, you see, don't these guys look similar to each other? Let's try. What happens if I was to factor out an x squared? Factor out an x squared for this these group terms. This is called factoring by grouping. So I'm going to take these terms, factor out an x squared, and I'm going to get 2x minus 1. Oh, look, see that matches? And then that's plus 1 times 2x minus 1, right? You see that? So then I have two things that are the same. That means I can write it like this. I can write it as 2x minus 1 times x squared plus 1. So now I have pretty much everything I need. This over here leads to the factor x equals to 1/2, because if x is 1/2 multiplied by 2, I get 1. 1 minus 1 is 0, right? If you're not comfortable with that, then just solve the equation on the side. 2x minus 1 equal to 0. You add 1 to both sides. You get 2x equals to 1. And then divide by 2, you get x equal to 1/2, right? But that's what I said. Okay, so x is 1/2. That's another one of our roots that we found. Yeah? So far, we've found 3 of our missing roots, 1, 2, and 3. And then the last 2 come from this expression right here, x squared plus 1. But that is another case where there's no x term, which means, oh, it's so exciting. That means x. Well, let me factor this for you. This is x plus I, x minus I, which means I, negative I, and positive I are the other missing zeros, right? So let me write it like that. Negative I and positive I. Those are the other missing zeros. And following my pattern, I'm going to highlight those in orange. So awesome. We found 5 roots, and our degree of our polynomial was 5. So that means we found them all. Let's summarize our answer right here in the bottom left. Answer. Let's see. The zeros are 2, 3, 1/2, I, and negative I. Those are the 5 zeros. Okay, that's it, guys. That's it. All right. Have a good day, and I will see you in the next section.